Yes, hello, welcome back to another episode of Bronze Age Workshop. So today I'm going to cast a blade from fahlore copper. Fahlore copper is an alloy that was common in the early Bronze Age in Central Europe and is a type of arsenic bronze. In fact, fahlore copper probably was not a man-made alloy, but simply the product of smelting a copper ore common in the Alps, the so-called fahlore. Fahlore is a polymetallic copper sulfide that is rich in arsenic and antimony, also sometimes containing significant amounts of other metals like bismuth, nickel, or silver. So just by using this type of copper ore, when you smelt copper out of this ore, depending on the conditions, of course, of your smelting process, it yields you a copper that is rich in arsenic and antimony just by nature. And we remember in the copper age, people started to use copper for small tools. But the problem with copper is that it is a kind of soft metal. So it does not really hold a cutting edge very long, even if you cold work the metal. So not really suitable to or not really offering much of advantages compared to stone tools. But with arsenical bronze, so just copper mixed or having some impurities of arsenic in the 1, 2, 3% range, this yields you a material that is much different than pure copper. And there are several advantages of arsenic bronze compared to pure copper, and this is the reason why we saw a widespread use of arsenic copper in the beginning of the Bronze Age, when tin bronze wasn't yet invented. So first, from a metallurgical standpoint, arsenic gives you some enhanced properties during the casting process. For example, arsenic lowers the melting point of copper, so depending on the percentage of arsenic, you can lower the melting point of your copper by 100 or 200 degrees, which is kind of significant. It also makes the metal more fluid, so it's more easy to cast. And arsenic has a deoxidizing effect on your smelt, so it's less likely that you get bubbles in your final object. Another advantage of arsenical bronze is the cold working properties of arsenical bronze are much better than pure copper. As cast, arsenical bronze is almost as soft as pure copper. But when you cold work the arsenical bronze, you get a much harder cutting edge. In fact, arsenical bronze, of course depending on the content of arsenic, and we are speaking here about like 3 to 4 to 6% arsenic, you get a cutting edge that is almost as equal in its hardness as a low percent tin bronze. So only if you go beyond 8% tin in tin bronze, you get a material that outperforms arsenical bronze. So this is the reason why arsenical bronze for quite a long time was the material of choice. There are some disadvantages though with arsenical bronze. As you can imagine, arsenic is not really adding to your health, and the same is true for antimony. And because of the low boiling point of those metals, you have a constant loss of arsenic and antimony during the smelting process. So keeping an exact composition of your alloy is a little bit tricky, especially if you recycle the material. You are at risk of losing a fair amount of arsenic and losing the beneficial properties of your material. Yeah, and how to create fahlore copper? Well, the most easy method is straightforward, created out of the elements. So first what you need is copper. I have here this very finely granulated copper. Then you need a copper powder. Yeah, just powdered copper. Arsenic. This is a piece of arsenic. As it occurs sometimes in nature, this is very pure arsenic It's heavy as lead, very heavy, and almost 2 pounds this piece here. And you just need a very small piece of arsenic, because in your alloy you only have some like 2 or 3%. So arsenic and antimony. This is very easy to find. Just buy it on eBay and get some chunks of antimony. Yeah, so the next step, I crushed the arsenic, or this as it's found in nature. This, I don't really know if it's pure arsenic or like whatever, 80%, 90% arsenic. So I used, actually for a 300-gram batch, I used 10 grams of arsenic, and then I mixed the arsenic in a 1-to-1 ratio with copper powder. And I also added 6 grams of antimony, so just a chunk of elemental antimony, and a euro coin. A euro coin is about 7 grams and consisting of 30% nickel. So do the math by yourself. It's like 2 grams of nickel. And I also added a tiny amount of, just a tiny piece of lead, like 1 gram of lead, probably a little bit lower than 1 gram, a little bit less than 1 gram, and also really a tiny piece of silver. Yeah, that's all. So I put everything, mix everything together, and I then put it in a paper towel and stuffed this paper towel with a mix at the bottom of my graphite crucible. And then I filled the remaining part. I topped it off with this granulated copper, 270 grams or so, to get to this 300 grams in total. And then I covered everything with ½ an inch or so of charcoal powder to prevent excess of oxygen during the smelting process. And this effectively prevents, or at least reduces a lot, any loss of arsenic. So let's compare our fahlore blade, the fahlore copper blade here, cold worked in a cold work condition, with cold worked copper, a cold worked 6% tin bronze, and a cold worked 8% tin bronze. So I'm gonna try to scratch the cold worked fahlore copper with a pure copper, and the pure copper does not affect our blade. So this is a proof that the fahlore copper, the cold worked fahlore copper, and even the S-cast is less harder than pure copper. So we can actually scratch and scrape some tiny pieces of metal of pure copper from the pure copper with our fahlore copper blade. So this is definitely harder than pure copper. Now let's try the 6% tin bronze. So the 6% tin bronze, the cold work 6% tin bronze, is not really capable of removing any pieces of metal here, causing scratches here on our fahlore blade. So it doesn't really affect our blade, and especially not the cold work part of the blade. So but we can see that our fahlore copper blade, cold worked fahlore copper blade, is capable of damaging the cold worked 6% tin bronze. So this blade is even harder than a 6% tin bronze. Let's go for the 8% tin bronze. And you know what? Now we see the limit of our fahlore copper blade. So the fahlore copper is not capable of doing any damage to the 6%, to the 8% tin bronze. So the hardness of our fahlore copper blade is in between a 6% tin bronze and 8% tin bronze, so really outperforming pure copper. And this, as I said, was the reason why people used or preferred arsenic bronze for quite a long time until the invention of high percent tin bronze. Yeah, this is all I can say about arsenic bronze. So we have seen that arsenic bronze or fahlore copper offered some advantages compared to pure copper, and this probably was the reason why we saw the widespread use of arsenic bronze in the early Bronze Age. Of course, until the invention of the tin bronze, which then outperformed the arsenic bronze and offered even more advantages compared to copper or arsenic bronze. Yeah, I hope you enjoyed my video about arsenic bronze. So I definitely do not recommend to smelt arsenic bronze, but just for the purpose of the video, I showed you the process. And if you have any questions, just ask them below in the comments. And yeah, so that's all I can say. See you.